Welcome all of you to one more video of Animaths. Now in this video we are going to continue with set theory like we have done in the past. In the last video we had done set theory. Once again we are going to take up the topic set theory because set theory is a continuation of set theory. So we are going to take up few more concepts of set theory like how we write a set, and we are also going to take up Venn diagrams, the very important Venn diagrams. So Venn diagrams is, I feel, it is not something which is necessary only for this chapter. Venn diagrams has a whole lot of usage, so you'll see how easy Venn diagrams are, sums based on simple sums based on Venn diagrams. Okay, but if you're watching my video, see to it that you are watching the previous video first. Okay, so you're watching them sequentially. That is going to clear your concepts much more. Okay, so let's begin with it then. Okay, so Venn diagram is nothing but a diagrammatic representation of a set. So we will first take how we represent subsets in a Venn diagram. So if we take this is the main universal set, that is nothing but a rectangle. So here if I make a set B and then I make a set A inside it, okay, and this is the universal set. Then if I write 1, 2, 3, 4, 5, 6 and 7. So A is a subset of B and B is a subset of the universal set. Remember, A is also a subset of the universal set. A is a subset of B, B is a subset of the universal set, A also a subset of the universal set. So this is how we represent it. What are the elements of A? 1 and 2. What are the elements of B? Elements of B are 3, 4, 5, 1, 2. Okay, elements of the universal set is 1, 2, 3, 4, 5, 6 and 7, everything. Okay, let us come to complement. Now if I write complement of the set B, it is very easy to find out the complement of a set from the universal set. So complement has been explained in the previous video. Here complement is what is not there in B but there in the universal set is 6 and 7. Okay, if I take what is complement of the set A, then it is 3, 4, 5, 6 and 7. Okay, so these are the elements of the complement of the set A. Now from this set itself, if I say what is the intersection of the two sets. Okay, now let us see another set where we will learn intersection of the two sets. Now here I have two sets which is again in a Venn diagram. The rectangle forms the universal set. A and set B are intersecting, that is they are overlapping sets. They are overlapping for 4 and 5. Okay, I have talked about overlapping sets in the previous video. So they are overlapping for 4 and 5. Now there is something called union of sets. Now what are union of sets? Union of sets are those sets which are those elements which are there. If I say A union B, now A union, this U represents, capital U represents union. So A union B are those elements which are there in A as well as in B. Now union means unity, union means together. So you have to take together everything. So 1, 2, 3, 4, 5, 6, 7 and 8. Yes, that forms my A union B set. Means I will take all the elements of A and B. Note that I have not taken 9 and 10 because it does not belong to B or does not belong to A. But then I will not repeat 4 and 5. That you have to be very careful about because we never repeat elements in a set. Okay, now come to the next one, which is intersection. Intersection of sets. Now intersection means common. Okay, the intersection of the two roads means where the two roads meet and the part which is common for both the roads. Okay, that is intersection of two sets. So it is the common part, and intersection is written like this, inverted U. Okay, this is, I'll write it again. Yeah, so it's an inverted U and is equal to 4 comma 5. A intersection B is 4 comma 5. Okay, that is only the elements of the common part. So this is A intersection B. Remember that this one, A union B or A intersection B, they themselves are sets. This is what people forget. They themselves are sets. Okay, so if they themselves are set, here you have to follow all the rules of sets here. You have to follow all the rules of sets here. Like I have used the curly bracket, I have used commas, I have not repeated any element. Every rule of a set is followed here. Okay, so that is intersection of sets, that we take the common part. Now if we want to do disjoint sets in a Venn diagram, how will we do it? Just now what we did was overlapping sets. Okay, now we'll do disjoint sets. We have talked about disjoint sets before in the previous video, but now we are going to draw that disjoint set over here. Disjoint sets are sets which do not have anything in common. So they are completely disjoint. The previous one was overlapping. So intersection, so A, B, 9, 10, 1, 2, 3, 4, 5, 6, 7, A intersection B in this case is a null set. Now this is a very common place for mistake where you are, don't put 0 over here. No, if you put a 0 over here, if you put a 0 over there, it becomes an element. Since there is no element in A intersection B, you are going to leave it like this, which is the sign of a null set. Okay, so A intersection B is a null set. Of course, you can write A union B. And now let's see what you get for A union B. 3, 4, 5, 6 and 7. So A union B answer is same, but A intersection B, this time you get a null set. So that is what are disjoint sets. Now we'll talk about difference of sets. Okay, difference of sets. Now what are difference of sets? Supposing you have a set here which is set A, set B, and you have the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now if you want to write like, there's something like this, A minus B. Now remember, difference of set, A minus B itself is also a set. Okay, A minus B itself is also a set. So here we start with difference. Now difference means from the set A, take out each and every element which is present in set B also. So we have to completely cut out, and this is my difference of set. So we are going to, so difference of set is 1, 2, 3, 4, 5. Okay. B minus A is again 8, 9, 10, means from B we are taking out everything that is there of A. Okay, so we are going to 8, 9, 10, 11, 12. These are the elements for the set B minus A. 1, 2, 3, 4, 5 are the elements for the set A minus B. As I said, they themselves are also sets. Okay, now we'll do one thing. I shall be shading all the areas for intersection, union, difference, disjoint, overlapping. Yes. So A intersection B. Okay, so this is A, here is B, this is the universal set, this is the area, shaded region is the A intersection B. Let me draw A union B. A union B is, and okay, now A union B is, you have to shade the full area. Okay, this makes A union B. Let me draw A complement. A complement is, this is the set A, then A complement is this, because this might help you to remember it better. This is A complement. Okay, that is everything else other than the set A. Now let's take up A minus B. Okay, so A minus B is A, B is the universal set. A minus B is this area. Okay, so if you learn it area wise, it's easier. So this is A minus B. Let's talk about B minus A. Okay, so B minus A is what? B minus A is A, B, this part. Okay, so B minus A is this shaded region. So I repeat, A union B, you have to take the entire region. A intersection B, only the overlapping region. A complement is this outside A. A minus B, only that part of A which does not take B. B minus A, only that part of B which does not take C. Okay, remember we can have Venn diagrams even for 3 sets, more than 3 sets we can have. Okay, supposing I have a set C. Yeah, so I have a set C. Okay, this area then becomes A intersection B intersection C area. Okay, and if I want to draw union, if I want to make union of these 3 sets A, B, C, then I'll have to shade the entire portion. Okay, so here also I can have another set. Now I'll just make one small change here. If I make a set B, then what is set B minus A in this case? So if I want to write B minus A for this, then what is it? Okay, B minus A for this diagram is a null set. Sometimes it will be confusing like this. Okay, A minus B will be this portion. Okay, like that. We'll now take up one sum. Okay, this is how the numericals are asked. U is 11, 21, 31, 41, 51, 61. Yes, and okay, and also 71 and 71. And A is, the set A is 51 and 71. The set B is 31, 41, 51. Okay, then what are the things we have to find? We have to find A complement, we have to find B complement, then we have to find A complement intersection B complement, and we also have to find A union B. Okay, so these are the 4 things that we have to find. Now A complement is, now note every time I'll be putting a curly bracket. I will see this and leave out these 2 from this set and take the rest. So 11, 21, 31, 41 and 61 is my answer. Okay, B complement is now 31, 41, 51 will be left out, and the rest 11, 21, 61 and 71. Okay, so I have 11, 21, 61, 71. These are the ones for B complement. Now I want to take A union, A intersection B complement, which is A intersection B complement is this one. Now remember, we are not going to find the intersection between A and B anymore. We are going to find the intersection between these two sets. So 11 is there, 21, 11, 21 is there, 61 is there, 61 is there. Okay. So 11, 21, 61. These are my complements. A union B. A union B is going to be everything that is there in A and that is there in B without repeating anything. But I can see 51 has been repeated, no problem. We'll write it only once. 51, 31, 41. The sequence does not matter. So this is A union B. So this is how systematically, actually these sums are pretty easy. But then sometimes if you miss, supposing when do people go wrong? When they have asked this maybe and not asked these two. Then students don't write these two like this. They will try to straight go to this part, the intersection part, and that is where they go wrong. So see to it that in these sums you are writing every step. Even if not required, you are supposed to write A complement, B complement. Then it will be easy for you to find the intersection of these two. Okay. So next sum. Now here is a question. Sometime. Now if you note this, this is the way sets are written. There are three ways of writing a set. The first method is descriptive method. The second one is a roster method. That is how we were listing out the elements before this. Okay, all this time we were writing 1, 2, 3, 4. Now this is the third method, which is called the set builder form or the rule method, where you don't write the elements but you give a rule for it. Now how do you read it? This is the one people find very difficult. A is such that, this is read as A is such that A belongs to the universal set, means belongs to this, and A is even. Now what is the universal set? This is written in set builder form. X is such that X belongs to natural numbers, N is for natural numbers, and X is less than equal to 30. So what we should first do is all these sets from the set builder form or the rule method, we have to get them in the roster form, which is the list. So I will write U in the roster form. Roster means roster. This is roster. Okay, and this is set builder. Set builder method of writing a set. Okay, so roster method is, now X is such that X has to be an even number. X, what is X? X is the elements of the set, and it has to be less than 30, less than equal to 30. So I start with 1 because natural numbers start with 1, 2, 3, 4, 5. Now I can't keep on writing till 30. I'll just put dots and do this. Come to A. We have to write that also. A belongs to this, but it's an even one. Means A belongs to this. Basically A is a subset of this, but it has to be an even number. So if it's an even number, 2, 4, 6, 8, 10, 12, 14, 16, like this it goes till 30. Okay, of course it has lesser number of elements. B. B is a multiple of 4, means it belongs to U only, but then we have to pick up the multiples of 4. So it is 4, and then it is 8, and then it is 12, and 16, and 20, and 24, and 28. That's it. Okay, we don't have any more multiples of 4. They are supposed to be 7, and we've got 7. Okay, so this is how we first change this from set builder form to roster form. Once we change it from set builder form to roster form, we are now going to start with our sums. Now what are the sums they have asked us? They have asked us A union B. What else have they asked us? A intersection B also they have asked us. A minus B they have asked us. B minus A also they have asked us. We are going to find these values now. Okay. Cardinal number of A intersection B they have asked. What else? Cardinal number of A, cardinal number of B. Cardinal number of A and cardinal number of B. So they have asked us these 7 things. So we are going to find it out. A union B. A union B is, what is A union B? Now note one thing. See, don't waste too much of time in this. This was even numbers, this is multiples of 4. All multiples of 4 are actually even numbers. So A union B without wasting time is nothing but because this full thing is a subset of this. So if we try to find A union B, then in A union B we are going to write all the elements of this, that is whatever is there in set A, 2, 4, 6, 8 till 30 it goes. Okay, all the even numbers come in A union B. Okay, let's talk about A intersection B. In intersection B, only these will be common, isn't it? Because they are also there, because these are even, these are also present here. So this full set becomes the intersection. So 4, 8, 12, 16, 20, 24, 20, 24 and 28. That is my A intersection B. A minus B. Now we'll have to throw out these and write the rest. Okay, so we will write 2, 6, 10, 14, 18, then 22 and then 26 and then 30. These are the elements of A minus B. Okay, come to cardinal number of set A. How many elements are there in set A? If we count 1, 2, 3, 4, 5, 6, 7, 8. After this 18, yes, 18, 19, 18, 20, 22, 24, 26, 28 and 30. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 and then we have 7 more. So a total of 15. Here we have a total of, how many numbers are there in set B? We have a total of 7. So these are not sets, so you don't have to put the curly brackets. A intersection B, how many are there? 1, 2, 3, 4, 5, 6, 7. Okay, these are the number of elements. B minus A, B minus A. Okay, from B, if you take out all the elements of set A, all will be taken out. In that case, it is going to become a null set. Okay, so this is how you have to work out these sets. Remember, doing this is the main key to getting your answers correct. This you must write. They will not tell you to write. Don't try to look at the set builder form set and try to get your numbers. Okay, you'll never get them right. So you have to list them out and then you have to work like this. Now here we have a Venn diagram and questions are based on this. They have told us find A union B. Find A union B. Remember that also is a set. A union B, 5, 3, 7, 9. Now 9 isn't C, no problem, take that also. 11, 12 and 13. That is A union B. I've taken everything in A and B without repeating. Let's take A intersection B. A intersection B is what? It is only 7 and 9. Let's take next question they have asked is A union B union C. Means all elements which are there in A and B and C has to be written together. So 5, 3, 7, 9, I have finished with A. Then 12, 13, 0, 6, 4. Then comma 12, 13, 0, 6 and 4 and then this 11 is left. Yes, so 11. Completely everything you have to write. Then let's take, now there is a question which is A intersection B union C. B union C. Now whenever you get a question like this, you are supposed to solve this first clearly. So B union C is what? In B union C we'll take everything of B and C. 7, 11, 12, 13, 9, 0, 6, 4. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8. It's good to count. Okay. So I've got 8 over here. Now this one with A intersection. which is common with A. With A, B union C has this one common and this one common. Okay, I don't think anything else is common with A. So here 7, 9. Okay. Now one last question. A union B intersection C. Okay. Now here again we'll find B intersection C first. Let's see what is B intersection C. B intersection C is 9, 11, 12, right? 9, 12, 13, sorry. 9, 12, 13. 9, 12, 13. So we have B intersection C with that union of A. So we have to join up. So 5, 3, 7. Yes, 5, 3, 7, that was in A, and with that let me join up B intersection C. So 9 we are getting from that intersection only, 9, 12, 13. Okay. So basically when they say A union B intersection C, you know what I should shade? I should shade this. Okay. If they say A intersection B union C, A intersection B union C. Okay. If now they say A intersection B union C, for this part, this is the shaded portion, the entire shaded portion, this and this also. Okay. This is A intersection B union C, means whatever is getting intersected, that is only the, after B union C, only the 7 is coming up from the intersecting part with A. Okay. So this is the shaded part of this. Okay. So you have to understand this chapter like this. Okay. So that is it today in set theory. I have tried to cover as many different types of things in this chapter as possible. Okay, so you can do the exercises. Remember, set theory also needs some practice, because things, you can miss out things, you can forget the rules of the set of the chapter. Okay, there are too many rules, there are too many names here, and then there are too many symbols in this chapter which you might not have learned earlier. Okay, so that is it for today. If you have liked the video, do not forget to like, share and subscribe. Thanks all of you.